Hi and welcome back. So let's take a look at property decorators now. We've seen properties, we know what they are. For example, we can create a property object, and of course we don't have to define it inside a class. A property object is just an object that just needs to be told about, the getter and the setter and the deleter and the docstring. Okay, so we could create it this way. We could say fget equals, and we can say lambda, and lambda is going to take a argument. It's by default we're going to call it self, because it will get called as a method when we do assign it inside a class and we access it through the instance of that class. So here I'm just going to say print getting property. So it's just going to print that out. Now I don't have to use fget. We can use positional arguments as well. So we can also do it this way. So P is really just a property object. Now, there's no way for us to call it right now. It does have attributes. If we look at, let's say, property .dict, it is an object, and it's got a bunch of things. It's got, for example, the fget. If we look at fget, we'll see what that is. So we can look at p.fget, and you'll see that it's this lambda function. It happens to be this lambda function that we created over here. So it has this fget as an attribute, essentially, on that object. So we'll come back to that in a second, and then we'll also come back to these, which are methods that are available on the property object, the getter, setter, and deleter method. Let's talk about decorators again, and I just want to refresh your memory on decorators. Let's go back and see how decorators work, and then we'll look at the decorator syntax. So let's go ahead and let's create this class. Let's call it myDecorator. And it is a function that's going to receive a function as an argument. And let's print some statements here. Decorating function. And then we're going to define another function inside. It's going to receive arbitrary positional and keyword only arguments. And inside, when this function is called, we'll say running decorated function. And what we're going to do here is we are going to get the result of calling function with the args and kw args. So whatever arguments get passed to inner, we're going to pass them on to this function over here. We'll calculate the result by essentially calling the function, and then we'll just return the result. Okay, so to make this a little shorter, I'm just going to return it directly, like so. Okay, so that's our inner function, and now we're going to return the inner function. So when we call the decorator, we're going to pass it a function. It's going to then return a new function to us, and when we call that new function, it will call the original function, but it will do some extra work as well. So let's start with our undecorated function now. Let's go ahead and create a function. Let's say it takes two positional arguments, and we'll say print running original function, like so. And then we're just going to return a plus b. So we're just going to do the sum of those two. Now, of course, we can call undecorated function, and we can pass it, let's say 1 and 2, and you see we get our print statement running the original function and the return value of 3. But instead of doing this, what I'm going to do now is I'm going to say, okay, my decorated func, so I'm creating a new symbol called decorated func equals, and now I'm going to call my decorator, and I'm going to pass it the undecorated function as an argument. Okay, so what is going to happen? Inner is going to be defined when this thing runs. Inner is going to be defined. It will have a reference to the function, so to the undecorated function. So inner is a closure, and the free variable is fn. And then it's going to return this new function. So now when I have this, you can see that this code ran because my decorator was called. So it was called, it printed this, defined this inner function, and returned it. So decorated func at this point is what? Decorated func is, if I can type it, it's the inner function, right? It's this function over here. But it is a closure. It knows what the original function was, this fn, which is what? It was my undecorated function. So now I can call my decorated function, passing it 1 and 2, and what's going to happen? Well, if I type it right, what happens? As you can see, we get running the decorated function. So the inner function was called, it printed this out, it then called the original function that we decorated. So the undecorated function was called, and so it printed running the original function. It returned 3, and this in turn returned 3 as well back to us, and so we get it all the way up here. So that's essentially how we decorate functions. It's basically just a function that wraps itself around another function, and usually that inner function is a closure because it needs to know what the original function was. So one of the things that we can do is we don't have to give this a new name, right? This undecorated function that exists, that's an object in memory. We can reassign the decorated function back to the same symbol. So instead of writing it this way, we could write it this way. We could say undecorated function equals my decorator of undecorated function. Now, undecorated function is kind of a lie because it is not undecorated. If we look at that, it is the decorated function, right? It is inner. But essentially, that's what we do with decorators. We replace the original function's symbol with the new decorated function. And so that's what the @ does in Python. It's just a shorthand way of doing exactly this. And so instead of doing all this rigmarole, we can start with our function over here. And so now I'm just going to call it, let's say, myfunc. And then all we need to do is to decorate it. We need to tell Python, okay, run it through the decorator and replace whatever myfunc is at this point, that's defined, that's an object, replace it by decorating it. And so now we can call the decorator, which is my decorator. So my decorator, like so. So basically this syntax over here is essentially the same thing as saying here, myfunc equals my decorator of myfunc, where myfunc would have been this function over here, def myfunc. And so when we do this, we now have, as you can see, it printed out decorating function. And if we call myfunc, let's say with 1 and 2, well, we get the 2 print statements and 3 back. So just a quick recap on how decorators work in Python. Now, one of the things that's interesting about the property is that when you create a property, it returns the property. So think about what this means. This means that property could be used as a decorator because property takes what? It takes a function. Right now, I'm only looking at the getter. So it takes a single function, right? The getter in this case. So we're basically taking a function, wrapping it inside something else, and returning this new property object. Well, yes, we could do this. If we're in a person class person, right? And then let's just do our init and self common name. And I'm just going to use a private attribute directly here for now. Now I can go ahead and define this function getName, okay? And it will take self, and it's just going to return self._name, and then we can create a property called name that's basically going to be a property that takes the getName function, but now it's going to assign it to this attribute value here, name, right, in my class. Well, instead of doing that, if you think about what the decorator syntax does, what happens if I just say @property over here? Well, this function is going to get created. It's going to get passed into property just like it does over here. And then our class is going to have an attribute called getName. It would be the same thing as saying getName equals property getName. That's essentially what's happening. So here, what I'm going to do, instead of calling it getName, I'm just going to call it name, which means that in essence, what we're doing is this. We're first defining the name function. So let me do it in 2 steps, okay, like so. Get name is that, and then I'm going to redefine name to be the property. So I can do this. So now I can say p equals person, let's say John, and then I can say p.name, and it's actually calling the getter. So let me go ahead and say here print getter call, just so we can see. And let me fix that. And you can see the getter was called. So this should remind you of the decorator syntax. So instead of doing first defining the function name and then creating a new object, a property object using name as the getter, and then reassigning that, basically overriding what name currently was, which was a function, to now being a property, but now it has a reference to the function that was created at this point, we can just directly use the syntax, the decorator syntax, and do it this way. So that's actually how properties work in Python. Usually we use the @property decorator, and you probably have seen that before, but now you should understand what's actually happening. We're creating a property object, and then we're using the decorator syntax to redefine the function name, which will be called as a method later, but the function name to redefine that now as a property object. So now we can go ahead and create our person, and now we can call p.name, and we get precisely that. So now let's go back to the property object. I showed you that the property object, so this is the class now, the class property. There is a dictionary on it, and we can see that it has a variety of things. It has this getter, setter, and deleter in particular. You'll notice that it also has properties fget, fset, and fdelete. So let's go ahead and create a property, but I am going to define this time the getter as I create the property. So I could use a lambda, but what I'm going to do is I'm going to create my functions so that I have a name for them so we can actually see what's going on in the objects. But you don't have to, we could just use a lambda here. So let's go ahead and call this getProp, for example. Now this will be called as a method, as we know, so I'm going to have that self in there, and this I'm just going to pass. I'm not going to actually do anything with that. Well, actually, let's go ahead and just say return getter called. So let's do that. Then I'm going to define another one called setProp, and now of course this is going to end up being a setter method, so I need to pass in self and whatever value I want to set. And again, I'm not going to do anything other than just say return setter call. And then we could do the same thing with a delete. So def del prop self comma value. We don't pass a value for the deleter. And then I'm just going to return deleter called. Okay, so these are just three functions that don't do much. Now I'm going to create the property, and I'm going to specify the getter for that property. So now I have an actual fget that's been defined on that property. And as you can see, it's the getProp method. But there is nothing for the fset. If I look at p.fset, you'll see that it's not returning anything because it's not printing anything out because it's the none type. So fset is currently set to none. And the same thing with fdel. Okay, those are all set to none. So now what I want to do is I want to be able to assign the setter to this property p. Now there's no way I can do that. And the instance, by the way, doesn't have a dictionary either. If we take a look at that, we get an attribute error. It tells us that p doesn't have a dictionary property. And we'll come back to this. I will show you that later when we talk about slots. But the instance here of the property doesn't have a dictionary. We can look at the directory p. So this function actually will find a lot more stuff than just what's in the dictionary. So over here you'll see that we have this fdel, fget, fset. So these are attributes on the object p, and then we also have this deleter, getter, and setter. And these are the functions or methods that we're going to use. So right now fget is defined, but I have no way of setting the fset directly on p. Instead, what I have to do is I have to call the setter method of the object p. And here I can give it the function that I want to use. So I can do that, and let's go ahead and let me create that as p1. Because what's kind of interesting here is that p is not p1. It's a different object. So you can think of the property as kind of a immutable type. So in order to have a property that I start off with that has the getter defined, and now I want to add the setter, essentially Python is going to create a new instance of a property object, right, of the property type. It will, however, grab the fget from P. So because I'm calling the setter method on the object P, it's going to grab the getter from P. It has the setter that I'm passing it here, and it's going to return a new object that will have both the getter and the setter defined. So now if I look at p.fget, and if I look at p1.fget, you'll see that even though they're different objects, the functions, the fget functions are the same, and then p2.fset is also been defined. Actually p1, sorry, .fset has already been defined as well. It's the set property, right? And then the p1.fget, of course, is our getProp function, okay? So this is kind of what's happening. We create this property P first, then we call the setter method, get a new object back, and then we assigned it to P1. Well, I don't have to assign it to P1. I could just as easily start off this way. So let me go ahead and start off just the way we had. So P equals property get prop. Next, I'm going to call the prop, the P.setter, and I'm going to pass it set prop. But instead of assigning it to a new symbol, I'm going to reassign it to the symbol P, like so. Now we could create a class person. So let me go ahead and do that. And then all I'm going to do here is create name equals P. Okay, and now I'm going to say person equals person instance, and now I can call person.name, and of course it's calling the getter. It's calling the getProp function, but bound of course to person, but I'm not actually doing anything with the bound object. And then if we do an assignment like so, then of course the getter is going to get called, the setter is going to get called, and I don't see the return value, so let me do it this way. Let me go ahead and say print, we'll just print directly, because the assignment doesn't return a value, the assignment operator doesn't return a value, so we need to be careful with that. So the print will always just print it out to the console. So let's go ahead and fix that, and then we'll rerun all our code, but nothing changes other than when I do the assignment just now, we'll actually see this printed to the console. So fget, fsetter, again, they're not the same. Okay, so now fget and fset is the getProp and setProp. We can go back this way again. We create our class. Now, when I go ahead and set the name, you can see that the setter was indeed called. And then we could do the same thing with the deleter, right? So it'd be the same thing, except we'd say p equals p.deleter. And if we do it here, p equals p.deleter, and then we'll call the delprop. Okay, so we'll use that. So we'll pass delprop as the argument here. Now, when I do this, I can go ahead and call the setter, but I can also say del person.name. And as you can see, the deleter method was called. Okay, so now let me redo exactly what we did here, but I'm going to do it a little bit differently in terms of how I'm naming things. So the first thing I'm going to do is I'm going to create a function called name, and it's just going to be self, and I'm just going to print getter, like so. So now I've got a function called name. Next, I'm going to reassign name to be the property, but I'm going to pass it name. So remember what happens. This right-hand side gets evaluated first. So now it's going to create a property object with the getter set to whatever the function here was. I can go ahead, if you want, and say ID of name. So I can run that. It's got a specific memory address. And let's do the hex to keep it a little shorter. Okay, like so. So now I can create a name property. I can create a property object, passing it name, passing it this function over here. And now the result of that gets reassigned to name. So now name is no longer the original function, right? The type of name is a property, and hex of ID of name is not going to be the same as the original. However, hex of ID of name .fget is the same as the original. So you can see that we have a property. It's a new memory address, but the fget is essentially this function over here, right? Just because we rename the symbol for the function doesn't mean the function disappears. It still exists as an object in memory, and now property has a reference to it, right, in its fget attribute. So now that we've done that, we now have this property, name. So now I'm going to do this. I'm going to say name temp equals name. So basically I have now a second reference, a second symbol that references this property object that's in memory, this one over here. Now what I'm going to do is I'm going to redefine the function name. But this time I'm going to define it this way, and I'm just going to print setter, like so. Okay? So now what do I have? Well, I have the ID of name, and the type, of course, of name is a function now, right? It's a function. So, but name temp is still around. So what I'm going to do now is I'm going to say name equals, I'm going to take name temp, which is the property, I'm going to call the setter method, and I'm going to pass it the new name function that I just created. So I'm doing kind of the same thing that I did with the getter, except now I'm doing it with the setter, but I am using the existing property, calling the setter method, passing it the function that I want for the fset. What happens is that I'm going to get a new property object, and I'm going to basically assign it to the same symbol name. So now if we look at type of name, that is now going to be a property. The hex of ID of name, of course, is going to be a brand new object, but the hex of ID of name.fget and hex of ID of name.fset. Let's take a look at all of these. So name is a property. It's a brand new object. But if you look at the fget, this B158, that's the fget that we had right from the beginning, right? That's this original function over here, this B158. If we look at the fset, it is C80, this 3C80, which happens to be this function over here that we just defined here. It is that one. And now we have a property that has both the fget and the fset. So this is no different than what we were doing before, except you'll notice I'm kind of bouncing back and forth between the function name, the property name, then another function called name, and then again the property called name, and so on. And this is because this should really remind you of decorators. And this is exactly how we can do that in our class. So I could continue this and do the deleter as well, but I'm not going to. Let's keep it to just the two. And let's now redo basically those steps, but inside our class using decorators. So the first thing I'm going to do is create the init, and then we'll use a private variable self.name. Next, I want to create a property called name. So I'm going to define the getter first, and I'm going to return self._name. But of course, I'm going to basically feed it through the decorator. So at this point, what I'm doing is I'm defining name, and then I'm saying name equals property name. Okay, that step is exactly what this is doing over here. So at this point, name is a property. Now, I'm again going to take the name property, but I'm going to call the setter. So now I'm doing what I was doing over here. I had to use a name temp because I first defined the function here. So by now, my name is now a function. I need the original property, but if you'll notice, I'm just calling the setter of the property and passing it the new function. So here, I don't have to do that. At this point of the code, name is still a property. So I'm getting the method setter. And now what I'm going to do is I'm going to feed it this function, this new function. That's going to be my setter. So here, self._name equals value. So it's going to create this function, pass it to the setter method of my name property, and then it's going to replace it, right? The symbol name is going to be replaced with the new property. So it's no different than what I did over here, right? I'm taking this new function name, passing it to the setter method of my property and then renaming name, basically repointing name now to this new property. So it's really important to understand this step over here and the previous one, because this name, because it's a decorator, the end result is going to be named, the symbol, right, is going to be whatever the name of the function is. So same thing here. The end result is going to be whatever this symbol is, because that's how decorators work. So if I call this something else, if I say name.set, for example, then my end result is not going to be name anymore. It's going to be name._set. Let me show you that. Let's go ahead and create a person object. Let's say Alex, okay? Now, if I look at the person class, if I look at the dictionary, let's see what I have in there. You'll notice I have two properties. I have the name property and the name set property. That's because this created a property. Now this also created a new property by calling the setter, but I didn't replace what name was. I called it a new name set. So now I have two things in my person class. So I can still get name this way, but I cannot set name equal to a value because it doesn't know what the getter is. It doesn't have a setter. It doesn't know what the setter is. So what I have to do, I would have to say name set equals Eric. That would be fine. And if I look at the dictionary, right, the underscore name is indeed Eric, and I'd have to retrieve it using p.name. So that's what happens if you rename this function to something else. So don't do that. Keep the same name because we want this to be consistent, right? If we look at our person dictionary now, it has a single property called name, and that's because we kept this name consistent with what we want the actual property to be. And the same thing holds if you're going to write a deleter. You need to do the same thing. And so now that we have that, let's go ahead and create an instance. So p equals person, let's say Alex. We can go ahead and say p.name equals Eric. We can retrieve p.name, etc. It works as a proper property with the getter and the setter. Now, the other thing I want to mention is that if you want a docstring, remember that the property function, the property basically initializer, takes in a docstring. Well, if you want to do that using the decorator syntax, all you need to do is just basically define your docstring inside your getter. So you have to do it inside the getter, and then we can just say the person's name. Like so. So now if we look at, let me go ahead and delete that. Let's go ahead and look at help on person.name, and you'll see that we get that docstring back, the person's name. So what happens if we define the docstring on the setter instead? Well, we could certainly try that. Let's see what happens when we do this. So I'll write it here. And if you look now, it's empty. There is no docstring associated with name. So what happens if we want a write-only property? Because we could technically create a property that has a setter defined, but not a getter. We can certainly do that. And so the question becomes, well, first of all, how do we do that? And then how do we set the docstring? So first of all, how do we create a property that only has the getter? Because if you look here, we have this property. By default, the first argument of property is always the getter. So we can't take this approach over here. So it's pretty straightforward though. We need to go back to the way we were doing it before. So we can just go ahead and say self.name and then actually I'm not even going to do any init because this is kind of a silly class. Let's go ahead and say prop equals property. And there's two ways we could do this. One is I could define a function here called prop set, right? Self value, and I could go ahead and print setter called. So that's one way of doing it. And then we just say here, we use now a keyword argument, fset equals prop set. Okay, so we could certainly do it this way. And then if we have an instance of person, we can certainly go ahead and say p.prop equals hello, that works. The setter is called, but of course we don't have a getter, so it's not a readable attribute. So that would be one way of doing it. The other way of doing it would just be to say prop equals property. So create an empty property and then assign prop this way. So I'm going to redefine this function to be called prop, and I'm going to say prop.setter. Okay, like so. So here I start by creating prop as an empty property. So it is a property object, and then I call the setter on prop, right? So I call prop.setters method, and then I assign it this property here. So now when I do that, the same thing happens. Again, the setter was called, and again, I do not have a readable prop property. So the way to set the docstring, essentially, if you only have a setter, is to specify it over here. So now we can say this is a write-only property, okay, like so. And so we do this, we can go ahead and look at help on our person dot prop, and you'll see that indeed the docstring comes through. But you cannot specify the docstring inside this. It only picks it up from the getter. All right, thanks for watching, and I'll see you in the next video.